I was not know.
Okay.
Okay, so this is the one we're gonna do first. Alright, so I want you to try to find the derivative of that.
Is that bottom to the power?
Yes. I'll give y'all like 3 minutes, or is that not enough?
Do you think there's gonna be a lot of questions about like finding the tangent, like the?
Yeah, there will be, yeah. There most likely will be at least one or two where you'll need to find the equation for that. Which is not too bad. I can explain it after we do this.
Yeah.
Yeah.
So this is another one where it's a chain wheel inside of a chain wheel.
Yeah, basically. I'll give you guys another like 30 seconds and then I'll start working it out for y'all. Alright, I'm gonna start. Are y'all good? Okay. So from here, we see that this top function here is f of x, and the bottom one is g of x. And we see that it's quotient rule because of that thingy. So what you want to do is the equation for quotient rule is g of x times f prime of x minus f of x times g prime of x. And then all of that is over g of x squared. So first we're gonna try to find this part here. So we have the g of x already, which is just e to the root of x plus 2. And then now we need to find the derivative of what's up top. So what I like to do when I have like functions with roots, I like to just change the root into the power of half. So it'd be x cubed plus e to the x, and then all of that to the power of 1/2. And then from here, what you want to do is you want to use chain rule, which is just f prime of g of x, and then times the derivative of the inside. So that's the chain rule, right? So what you want to do here is look at the function on the outside, which is the power of half. So when you take the derivative of that, you move the 1/2 in front, and then you hold whatever is inside, right? So it stays as x cubed plus e to the x, and then you need to subtract 1 from the exponent, and then it becomes negative 1/2. And then from here, you want to take the derivative of g of x, which is this part here, and then you multiply it by 3x squared by using power rule, and then we know that the derivative of e to the x is e to the x. So all of this here is equal to f prime of x. I wrote it a bit messy, but just imagine that this goes here. Yes?
When you're doing the 3x squared and then the e to the x, is that multiplication or is that an addition?
Oh, it should be addition. Thank you for calling that out. Yes. Yeah. So it should be like that. Okay, and then now we're trying to find this part here, which we have f of x, which is root of x cubed plus e to the x, and then we're multiplying that by the derivative of the bottom, which, if you guys remember, Professor McLaughlin, she told y'all that e to the power of x is just e to the x. So since e to the x is just e to the x, when you use this formula here, that first part here, it just stays exactly the same. So it'll just be e to the root and then x plus 2, right? And then what you want to do is multiply that by the derivative of the exponent, which, since there's a function on the outside, we'll need to do another chain rule. So that is basically just x plus 2 to the power of 1/2. And then from here, the outside function is 1/2, and then when you take the derivative of this, you do chain rule again, and then it becomes 1/2 in front, and then you hold what's inside of it, and then you subtract 1 from the exponent.
And that's the derivative of g of x?
Yes.
Okay.
So the derivative of g of x is this, and times 1/2 x plus 2, and then to the power of negative 1/2. So this entire part here is the derivative of g of x. And then this is what we plug into here. So it'll be this, which is g of x, and then times g prime of x, which was this whole thing here. And then you subtract that by f of x, which is this. And then we took the derivative of g of x, and we got this thingy over here. So it'll be this times that big old thing. And then all of that is divided by g of x squared, which we know g of x is just e to the root x plus 2. And then just put a parentheses around that and square it. It's a bit messy, but does that make sense? And on the test, there will definitely be a question or two where they ask you to find the equation for the tangent line. So if they do that, then they'll give you a function f of x, and then they'll usually also ask you to find it at a specific point, say like x equals 2. So all you need to do is, you already have the x coordinate, right? Because the equation for finding the slope of a tangent line is y minus y1 equals the slope times x minus x1. So since we already have that x, all you need to do is take the x value that they gave you, which is 2, and then you plug that into the original f of x equation, and then that gives you the y value to put here. And then from taking the derivative, which is this thing over here, that's the equation to find the slope at a certain point. So in order to find the m, you find the derivative first, and then you plug in the x value that they give you into that derivative, and that gives you the m. Any questions?
How would
Yes.
you solve for like each situation?
On the test, they definitely won't make questions this complex, and if they do, most likely they're not going to ask you to find the equation. They'll probably just tell you to not simplify. So just, yeah. All good? Yes?
Could you really quick rewrite
Mhm.
the like final answer?
Oh,
derivative?
yes.
Is it that? I can't.
I can write it here. Hold on.
Okay.
It'd be, I'll write it in another color. So the final answer would be this. So it'd be this, and then you subtract. You subtract root x plus e to the x. You subtract this times g of x, which is okay. I wrote a bit too big, so it doesn't look the best, but this is what's on top. So this whole part here is in here, and then on the bottom is it's all of this, and then divided by g of x squared, which g of x is e to the power of x plus 2, and then just square that. Any questions? Alright, I'm gonna move on to the next question then. Okay. I'll give you guys a couple minutes to work on that. But this, you just do products rule, and then there's 1 or 2 chain rules. I'll give you guys about another minute and then I'll start solving it. Is everyone good? I'm about to start solving it now. Good. Alright, stop me if you have any questions. So, the formula for product rule is just so that's the formula, right? And we see that this here is f of x and this here is g of x. So first we just write down the f of x, which is natural log of the stuff inside. Right. And then we want to multiply that by the derivative of this part here. So we see that the function on the outside is multiplied by 3 and then it's raised to the power of 2. So we see here that you want to do chain rule. So for chain rule, what you do is you take the derivative of the outside, which is you bring the 2 in front and you multiply it, so that becomes a 6. And then you hold the thing inside of the parentheses, so that stays as natural log of 2x. And then you subtract 1 from the exponent. Good? And then you multiply that by the derivative of what's in the inside. And you see there that that is another chain rule, because the function is natural log of 2x. And in class, she went over it how natural log of x, the derivative of that is just 1 over x. So you just write 1 over, and then you hold whatever is inside the parentheses and write that in the denominator. And then you multiply that by the derivative of what's inside the parentheses, which in this case is 2. So here the 2's just cancel out, and then it just becomes 1 over x. So this here is the derivative of g of x. So we write this here. And then for the second part, we need to find the derivative of f of x. So first we just write down the g of x, which is 3 natural log of 2x squared. And then we're multiplying that by the derivative of this here. And you see that the outside is a natural log again. So what you want to do is just do 1 over and then hold whatever is inside the parentheses. So in this case, it'd be root 3 root, and then 4x squared plus 9x. And then you want to multiply this by the derivative of the part that's inside the parentheses. And you see there that there's another outside function and an inner function, so you want to do another chain rule. So from there, you can rewrite that as 4x squared plus 9x to the power of 1/3. And then to take the derivative of that, you just move the 1/3 in front, and then you hold the inside. And then you subtract 1 from the exponent, and that'd be negative 2/3. And then you want to multiply that by g prime of x, which is the derivative of the inside here, which you would just do power rule for that, so that's pretty simple. It'd just be 8x plus 9. So it'd be this times this. That gives you the f prime of x. So here we have f of x times g prime of x, and then plus g of x plus, and then f prime of x, which we found here. All good? I'll write out the full answer now. So this would be the full answer. Did that make sense? Okay, so these two questions that I just went over, it was involving basically just double chain rules with product rule and quotient rule, which that's probably on the harder side of, I guess, derivatives for you guys. So on the test, questions, I highly doubt it'll be this complex. At best, it'll probably just have one chain rule. So it really shouldn't have to. And if it does, I think you guys have the hang of it, I believe. So it shouldn't be too bad. So, yes?
When it comes to product rule, does
Mhm.
it matter if, like, if we, like,
Uh-huh.
what if we reverse it and had the derivative, like, the 6?
Of
like, does
this
it
plus
matter?
that?
Yeah.
No,
like-
it would not
okay,
matter.
Okay, but it matters for quotient rule.
Yes,
products,
yeah, it
okay.
does. All right, and then another big thing on the test will, I'd say, this is not gonna be on the test, by the way. I don't know what that is. But you guys would need to find the derivatives using limit definition, which you can check the answer for that just using like normal derivatives, but there are some strategies that she went over in class with you guys when doing limit definition, so I'll just briefly go over those. So there's gonna be just two cases mostly there's gonna be one where you have a root and one where you have a complex fraction. So So these are two separate problems. I'll give you guys a couple minutes on those. And I'll write down the formula for limit definition if you guys didn't remember. I'll give you guys about another minute or so, and then I'll start. Okay, I'm gonna start now. So whenever you do limit definition for derivatives, there's usually just two main methods that you want to use. One is where you want to use the GCD, and that's for cases where it's a complex fraction. And the other one is where, I think it's called something like eliminating the square, and that's where you have the root. I'm not writing that out, but yeah. So what you want to do is first plug in f of x plus h. So that would be just change the x to a x plus h, and then plus 5. And then you subtract f of x, which is just x plus 5. And then all of that is over h. And then the method for getting rid of the square roots is you multiply the top and bottom by basically the exact same thing, which is just x plus h plus 5. Except you just swap the sign that's in between. So here it's a minus sign, so it would just become a plus. But if it was a plus, then it'd be a minus here. So just do this, and then plus 5. And then you also need to multiply the denominator by that too. So just this. And then once you multiply the top and bottom out, that should cancel out the roots. So that just leaves you with x plus h plus 5. And then you're subtracting x plus 5. And then all of that is over h times all that stuff right there. Good. So now what you want to do is find a way to cancel out the h's. So you first distribute that subtraction sign. So it would become x plus h plus 5 minus x minus 5. and then that'd be over h to all that stuff. And then if you see here, there's an x and then a minus x, so these cancel out. And then a different color. And then the 5's cancel out, and that leaves you with just the h on top. So from there, all you gotta do is just cancel out the h's too, and then that'll leave you with a 1 on top, and then over what we originally multiplied the h by, which is just root of x plus h plus 5, and then plus root of x plus 5. And then from here, you just take the limit of that as h goes to 0, which will just be equal to 1 over root x plus h plus root x plus h. Wait, no, not h, 5. And then that's your derivative. If they ask you to find the function of the tangent line or the equation of it, they'll give you an x value, so just plug it in as the x, and then that gives you the slope to plug in as n. And then you should be able to find that equation.
Can you say that again?
Yes. So if they ask you to find the equation of the tangent line, then this, since this is the derivative equation, they'll always provide you with the x value that they want you to find the equation at, say like x is 3. So all you need to do to find the slope is just plug in the 3 for the x's, and then solve that, and that gives you m, which is in the equation y minus y1 equals m x minus x1. So that gives you the m, and then that x value is just the x1, and then in order to find the y1, you just plug that value into the original equation.
Wait, what did you say about that, Mike? I'm sorry.
Oh yes. So to find the y value for the equation, just take the x that they give you and plug it back into the original f of x function. And then for this problem over here, you basically do the exact same concept, but instead of doing this elimination of squares, here's what you want to do. So it'll be 1 over 3x plus h minus 1 over 3x, and all of that over h. And then what you want to do is multiply all of that by the greatest common denominator, which is just this times this. So it'll be 3x plus h, and then times 3x. And same for the h here. And then once you distribute this out to both of these, this cancels that out, and it leaves just the 3x on top here. So it'd be 3x, and then minus. And then this times this, that leaves a 3, and then times x plus h on top. And then that 3x cancels out with that. So it'll just be 3x minus 3, and then times x plus h. And then the denominator is just h times all that stuff. I'm gonna erase a bit of this. So now what you want to do is just factor out that 3. So it'll be 3x minus 3x minus 3h over h and all that stuff. And then if you see here, these cancel out. That leaves just a negative 3h on top. So go back over here, and then it'll be negative 3h over, and then it's h times the 3, and then x plus h times 3x. And then these h's cancel out. And then this 3 cancels out with that 3. So that'll leave just a negative 1 on top, and then it's just divided by x plus h times 3x. And then now we're finding the limit of this as h goes to 0, which is just the same as negative 1 over, oh, that's so crooked, which is the same as negative 1 over 3x squared. Is everyone good?